Okay, so today we're going to talk about this thing called the mean value theorem. What does mean mean? Average. And this has everything to do with average rate of change. Okay? We have the same kind of similar conditions as extreme value theorem. F has to be continuous. We have to have endpoints, meaning a closed interval. Are y'all with me here? All right. We also have to have differentiability. What does that mean we're not going to have on our graph? What's continuous but not differentiable? Cusp. If you're thinking whole, you're right, but that's covered in the whole F is continuous thing. But cusp, we can't have a cusp. All right? This right here, extreme value theorem works with cusps. Mean value theorem does not work with cusp. Because cusp, derivative at a cusp is what? It doesn't exist. So, and this is going to be about derivatives and about slope and all that. Okay, so if those things are all true, then there exists a number C, and C has to be which type of value, X or Y? Which one? Can you take a vote? But if it's in the interval, intervals are always comprised of X values. Okay, here's another way that we can think of it. What would be a Y would be F of C. F of whatever, that's a Y value. Okay, now look at this equation right here. All right, let's break this down. F prime of C. What does that mean? The derivative. And what is the derivative? The slope of the tangent line. So the specific slope at a very specific point, we could say at one instant, instantaneous rate of change even. All of that has to equal f of b minus f of a, which is all over b minus a. This is the same as saying y2 minus y1, right? Because f of, those are y values. A and b, those would be x values. What does this look like? Just regular slope. We could say it's slope of a secant line. 2 points to be a secant line. That would be average rate of change. So I've been giving you little hints. Let's read this sentence, and then I'm going to see if you guys can fill in these blanks. Geometrically, the theorem guarantees the existence of a tangent line that is parallel to the secant line. What does parallel mean in this context? Same slope. So the slope of the what line? What's the line on the left?
The tangent.
The tangent line. So the slope of the tangent line by this theorem is going to equal the slope of the, what was the other one? Secant, and that's 2 points. And secant slope is just like good old-fashioned slope. Rise over run, 2 points, slope formula, all that. All right? Right here, we're going to be talking about rates of change, ROC, basically. Okay, do you remember which type of rate of change is associated with tangent and the derivative? Yeah, say it. Say it loud and proud. Instantaneous. Now, if you're like, I don't know how to spell that, spell the word instant, and then go aneous, like that. You'll never forget it. Okay, instantaneous rate of change, which is IROC, is equal to, sometimes it takes people longer than others. That's okay. It's Friday afternoon, right? Equals what type of rate of change? Average rate of change. Now, this is why this is called the mean value theorem. Here's the deal. I'm going over a lot of vocabulary. The better you understand the big concept, you're going to remember it. If you just try to memorize like specific skills, you're going to forget how to do this. In like one night's sleep, you're going to wake up tomorrow, you won't even know how to do this. But if it makes sense, and let's write AROC under here. Makes sense, you're going to remember it. Okay. This is all great stuff, by the way, to put on your theorem write-up when you do this on Monday. Okay. Draw the secant line. Now, sometimes people are like, what's a secant line? It's just a line between 2 points. Okay, so through A, f of A, and B, f of B. So here's A. If you're like, what does f of A mean? It's just the y value at that point. F of A. So through that point and through this point. And go ahead and even write f of B. So if you connect these two, that is your secant line. And it has a slope, right? Yeah, it's the average rate of change. This would be like you're driving, sometimes you're going fast, sometimes you're going slow, and you want to know what your average speed was by taking like how long did it take for you to get there and how far did you drive. It wouldn't, but instantaneous would be like specific points in time. Okay, so it says then sketch any tangent lines, and it says we're going to find the C by the mean value theorem. So we're looking for, is there a point between A and B on the curve where if I graph the tangent line, it would be parallel to the secant line? Do you see it?
It's the.
Is it at the very maximum?
No.
What's the slope exactly at the maximum? 0. So it's probably going to have to be like about right here. Okay, so that's one answer. There's actually another one. So there's one tangent that's parallel to secant. Where's the other one? Yeah, really kind of close to the minimum over here. Maybe like right about there. And what we're about to do is really kind of look at this in more detail. So here's where C comes into play. If I kind of see how A and B have those dotted lines. So there's a C value, and then down here, the C value is just telling you, hey, this is the X where this special thing is happening. Okay, example 2, apply the mean value theorem to this equation. All right, I am going to say that the first thing we probably should do is rewrite the equation, so that, whoops, that was too big of an erase bubble. I'm going to rewrite the equation so that finding the derivative is going to be easier. So you guys see what I mean? Write it like this, where x to the negative 1 instead of over x. Because I know, just by looking at this, by seeing mean value theorem, I know I'm going to have to find the derivative. Now, before I do that, we do need to just double check something real quick. Can we use the mean value theorem? Is the beginning part of our if statement, is that true? Is f continuous? Is there a closed interval? And do we have differentiability? So let me, and you guys have grid lines on your, so here's the closed interval. Check. Do we have continuity on the closed interval? Yeah. Yes. F is continuous on the interval 1 to 4. Do we also have differentiability, meaning does every point have a slope? Are there no cusps? That kind of thing. Yes? Okay, that is something we need to check if we're going to use the mean value theorem, okay? It's not that those things aren't going to happen, but when we kind of start getting into proofs, I'm not saying we're going to do a whole lot of that, but we need to make sure we list that out, okay? All right, we need to find the derivative. So what's the derivative? 4x to the negative 2. Now this is totally right. I'm about to have to like do something with this equation. It may be more helpful to rewrite it like how it was at the beginning. So what's another way I could write 4x to the negative 2?
4 over x squared.
Very good. 4 over x squared. Okay, so that's the left side. Now let me switch colors, and now I'm going to do the right side. Okay, so I did the derivative. I did the slope of the tangent line. I did the instantaneous rate of change. Now I'm going to do the other one, okay? You can even draw a line if that helps you. I didn't mean to cross through that, but that's whatever. I'm not going to redo it. I didn't mean to cross through that. I just meant to draw a line. So we need to do, in our case, these are our A and B. So I need to do f of B, sorry, one day, f of 4 minus f of what? 1 over just 4 minus 1. This is called the difference quotient. Remember that from when we did average velocity? What is f of 4? Yeah, how'd you get that? You looked at the graph? Did anybody plug it into the, what if I plugged 4 into the original? Same thing. Okay, what's f of 1? 1. Well, that's interesting. So I get 1. What is 1, though, in the context of this problem?
That's the slope.
The slope of what?
Secant.
Okay, so
No, not the secant. The secant.
so that line right there, the slope of the secant line, has a slope of 1. Okay? What we're about to do is show algebraically this equaling this. Okay, because what I circled in yellow. F prime of x, which is the left side, and if you wanted to, you could definitely write it as 4 over c squared. You could write in c instead of x. It's really not wrong to not do that. It would never take off, but it may be helpful for you to do it. So that it's really obvious, okay, we're about to find c. Okay, so what I've written here in blue, that's the left side. What I've written here in purpley, pinkish color, that's the right side. I'm now going to set them equal to each other. So 4 over c squared equals 1. And you're going to solve for c. So go ahead and do that. Solve for c. Some of you may be able to just look at this and see what the answer is. Some of you, you're like, let's cross multiply. That's totally fine. And if I do this, I get plus minus 2. Y'all agree? So my answer is positive 2 and negative 2?
No, because the closed interval is
Yeah, what's wrong with negative 2? It's not in this interval. And I'm only caring about this interval. So c equals 2, and that is the answer. Now, I do want to just double check my answer. So plot the point where c equals 2 and graph the tangent line. If these two lines are parallel, you did a good job. If they're not parallel, then we did something wrong. Okay, so the graph kind of backs us up. It's there as a support. You really don't need the graph, but it definitely can help. Okay, let's look at the next page. And we're going to skip the airplane problem, and we're going to go to this company problem. So a company introduces a new product for which the number of units sold, S, is given by this equation, where T is in time, is the time in months. So let's go ahead and, on our graph, let's go ahead and write units sold and number of months. And this whole thing is going to be talking about the first year. So where should my endpoints be?
1 and 12.
1 and 12?
0 and 12.
0 and 12, I agree. Now again, your paper is gridded a little bit better than this, but we're going to have to do a little bit of work here to figure out that y value. We'll get to that in a minute. So find the average rate of change. Average rate of change is saying, what is this slope? So in order to find a slope between 2 points, you need 2 y values and 2 x values. In other words, what we're going to do is do s of 12 minus s of 0 over 12 minus 0. Now, which of the things on this is going to be the hardest one to find? S of 12. All right, now, you can either go with the equation that's right here. If you're using your calculator, you can use your calculator, by the way, on this problem. So go ahead and get it out. And you could definitely plug 12 in and figure it out and all that kind of stuff. Let's just say, for some reason, your calculator wasn't working. And while you're getting your calculator out, let's think about poor old me doing this without my calculator. Look at what I did right there. That made the problem easier. even if you are using the calculator, this is an easier thing to deal with. I just distributed the 200. Okay, so S of 12, and if you're like, I don't want to do that, well then plug 12 into the original one. It really doesn't matter. So 1,000 minus 1,800 over 2 plus 12, that would be 14. So use your calculator and plug it in. 1,000 minus 1,800 divided by 14. And we're going to get an exact answer, and we're going to use the exact answer because this is only one piece to the larger problem. If I round in the middle of the problem, what's eventually going to happen? You're going to have rounding errors. You can only round your final answer. You can't round in the middle. All right, what about S of 0?
Okay, I'm confused what it's saying.
S of 0?
Yeah.
So if we plugged in 0,
Oh, never mind, I get it.
or we can look at the graph, but either way you get 100. So I get, and again, this is where having a calculator is nice because this is an awful lot of number crunching otherwise. It's possible to do without a calculator, but it's definitely helpful. Now, you either need to be careful, do this in 2 steps, or use parentheses, something. All right, now, I'm going to just tell you what you get on this one, because I want to keep going. You get 450 over 7. That's my exact answer. What would the units be?
Units per no.
Yeah, units sold per month. And this is a perfectly acceptable answer in our world. If this was your job and you were doing this like for your boss, they're going to say, that doesn't make any sense. Give me a decimal. And so, or maybe if this was multiple choice, you would have to write a decimal. Did anybody plug it in? It's 64 point something.
286.
So 286, say. Be accurate to 3 decimal places if you are going to round your final answer. We're going to use this number in a minute, and I definitely don't want to use the rounded decimal. So 450 over 7 is much more useful to me. That is the slope of the green line that I just drew. Okay, now let's look at the next part. During what month does S prime of t equal the average, don't get caught up in this word value, go ahead and just write rate of change. So this is mean value theorem. It doesn't say it, but it is, because it's saying when does a derivative equal a plane slope? So we need to find the derivative first of all. Well, if this is a calculator problem, can you let your calculator help you find the slope? Find the derivative? You could do this derivative by hand. It wouldn't be that bad. But if this is a calculator problem, why waste time with that? F3, differentiate 1,000 minus 1,800 divided by, I need to use a parenthesis, 2 plus t, and then I need to go comma t. Okay.
How do you get the differentiate?
F3. Now, earlier I had some people whose menus looked a little bit different, and I think someone who had their calculator before them, the settings were weird. I'm trying to figure it out. So if your F3 doesn't look like mine, let me know, and I can help you, or we can just reset the calculator to the default. All right, this is how you do a derivative. Now, it's not really helped you so much yet because I've made you do all this stuff without a calculator. And the nice thing about your calculator is it will simplify it for you. Like if we were to do quotient rule there, it would be all messy, but this simplified it for us. All right, let's move on. If you're kind of stuck on that, let it go and just get back with the rest of us. Okay, so this is the derivative. All right, again, I'm going to do this again. Here's the average rate of change. Here's the derivative. What are we going to do with those two things? Put them equal to each other. So 1,800 over 2 plus t squared is going to equal 450 over 7. I'm not going to use the decimal because the decimal was rounded. Just use the fraction. And again, if we're using our calculator, what's the easy way to solve this? I mean, cross multiply, okay, that's not the easy way. How about this? How about using the solve feature on your calculator? I'm just reminding you guys of this stuff. So 18, you know what? I don't even feel like typing that in. So I'm going to go up here, I'm going to grab it, I don't have to type it in. Equals, if you didn't know your calculator could do this, you learned something new today. Then you got to go comma t. It's always comma t, comma x. Now I got some weird answer. This says during what month, so this is where a decimal is appropriate. So I get 3.291, and it looks like I have a negative answer. Is a negative answer going to work here? No. It's not in my interval, and it doesn't even make sense. So t equals 3.292 months. This still doesn't technically answer the question. Okay, so this is where you use common sense. So math is good, but common sense has its place, and we all have to have common sense. During what month? You can either give me like a month of the year, or you can say like the 7th month. During what month is this happening? Okay. Everybody thinks it's March? Or during the 3rd month?
Oh, wait, no, the 0 to 1 is...
Keep going, Shay.
January, 1 to 2 is February, 2 to 3.
Yeah, that's the 1st month right here. This is the 2nd month. This is the 3rd month. 3 point something, like, let me go ahead and plot that up here. 3 point something is actually during the 4th month. Think of it this way. 3 point something months, 3 months have passed. All of January, all of February, all of March have passed. You're now into the 4th month. So it would say during the 4th month. Got to be careful with this type of stuff, and we'll continue to work with this. This is the first time we've seen it this year. I don't know why I wrote months. That doesn't make sense. Okay, so here's the next thing that we're going to do. Okay, first of all, let me just tell you, and this is good, I'm going to even put this on the video. 3.1 homework, that's what you already did, page 169. Okay, that's going to be due Tuesday. If you didn't finish it yesterday, you got the weekend to get caught up. We have a quiz on Tuesday. It's going to be over 3.1 extrema, like absolute extrema, and extreme value theorem, and 3.2, this is what we did today. Here's the assignment. This assignment is due Tuesday. So it's like your homework this weekend, although you might have time in class Monday, like if your test corrections don't take that long, you may have time to work on this Monday, and then that's your homework Monday, is to finish and get ready for the quiz. So that's what we got going on. Right now, you can either go ahead and get started on this assignment, or you can work on example 5. I will tell you, I'm going to encourage you guys to work example 5. All right, I'm going to pause the recording. I'm going to give you guys a little bit of time to work, and then I'm going to put the answers up before you leave. Okay, so right now, you're either working example 5, or you're working the book work, okay? One of the two. Oops, that's not what I meant to do. Here we go. I'm going to pause.